Hey there, science fans. Have you ever wondered what stuff is made of? Well, that stuff is called matter. Everything around us, from the chair you're sitting on to the air you breathe, is made of matter. Matter is anything that takes up space and has weight. Think about a big bouncy basketball. It takes up space, right? And if you tried to lift it, you'd feel its weight. That's because the basketball is made of matter. Even tiny things like grains of sand or drops of water are considered matter. They might be small, but they still take up space and have a little bit of weight. So, next time you pick something up, remember you're holding matter. Now that you know what matter is, let's dive into the different forms it can take. Get ready for some exciting science adventures. Hold on to your goggles because we're about to explore the three states of matter: solids, liquids, and gases. First up, solids. Solids like rocks, ice cubes, and your very own phone are firm and hold their shape. That's because the tiny particles inside them are packed tightly together like puzzle pieces that fit perfectly. Next, we have liquids. Liquids such as water, juice, and honey can flow and take the shape of their container. The particles in liquids are still close together, but they're a bit looser and can move around more freely, like marbles in a jar. Last but not least, we have gases. Gases like air, helium in balloons, and steam from a boiling kettle are all around us. Even though we can't always see them, the particles in gases are super spread out and constantly zooming around like kids playing tag in a park. So there you have it, solids, liquids, and gases. Each state of matter behaves differently because of how its particles are arranged and how much they move around. Pretty cool, huh? Get ready for a mind-blowing phenomenon called diffusion. Imagine dropping a few drops of food coloring into a glass of water. What happens? The color slowly spreads out until the entire glass has a uniform hue. That's diffusion in action. Diffusion is the movement of particles from an area where they're crowded to an area where there's more space. Think about it like this. If you open a bottle of perfume, the scent particles don't just stay put. They spread out in every direction, eventually reaching your nose. This happens because particles are always on the move, bumping into each other and spreading out. The bigger the difference in concentration, the faster diffusion happens. So, the next time you smell something delicious cooking, remember, that's diffusion bringing those yummy particles to your nose. Have you ever noticed that a puddle of water eventually disappears on a sunny day? That's evaporation, the process of a liquid turning into a gas. But how is evaporation different from boiling? Let's break it down. Evaporation happens at the surface of a liquid. When the sun warms up the water molecules, they gain enough energy to escape into the air as water vapor. This happens gradually over time. Boiling, on the other hand, is a much faster process that occurs throughout the entire liquid. When you heat water on a stove, the water molecules at the bottom get hot enough to turn into steam bubbles. These bubbles rise to the surface and escape into the air. So, both evaporation and boiling involve a liquid turning into a gas, but they happen at different temperatures and at different speeds. Next time you're boiling water for pasta or watching a puddle disappear, you'll know the science behind these amazing transformations. Section 5. Pure substances, elements and compounds. In the world of chemistry, we often talk about pure substances. What makes a substance pure? It's all about its composition, or what it's made of. A pure substance is made up of only one type of particle. Think about a shiny gold bar. It's made entirely of gold atoms, making it a pure substance. Another example is table salt, which is made up of sodium and chlorine atoms bonded together. Pure substances can be further divided into two categories: elements and compounds. An element like gold, silver, or oxygen is the simplest form of matter and cannot be broken down any further. A compound, on the other hand, is formed when two or more different elements combine chemically. Water, for example, is a compound made from the elements hydrogen and oxygen. So remember, pure substances are the building blocks of matter, and understanding them helps us unlock the secrets of the chemical world. Section 6. Kinetic energy, how particles move. Hold on to your hats because we're about to talk about energy, specifically the energy of motion, also known as kinetic energy. Kinetic energy is the energy that an object possesses due to its motion. Everything in the universe, even the tiniest particles, has kinetic energy. The faster something moves, the more kinetic energy it has. Think about a speeding train. It has a lot of kinetic energy. A snail, on the other hand, moves very slowly, so it has much less kinetic energy. But what does this have to do with matter? Well, the particles that make up matter are always in motion. They vibrate, rotate, and translate depending on the state of matter. And guess what? Temperature plays a big role in kinetic energy. When you heat something up, you're giving its particles more energy to move around. That's why a hot cup of cocoa cools down over time. It's losing some of its kinetic energy to the surrounding air. The particles slow down as they lose energy. So next time you feel the warmth of the sun or the chill of a winter day, remember it's all about the kinetic energy of those tiny particles. The energy of motion is everywhere. From the smallest particles to the largest objects, kinetic energy is a fundamental concept that helps us understand the world around us. So whether it's a speeding train or a slowly crawling snail, kinetic energy is always at play, shaping the universe in fascinating ways. The next time you observe motion, think about the kinetic energy involved. It's a powerful force that drives the dynamics of our world. And remember, the principles of kinetic energy apply to everything, from the microscopic to the macroscopic scale. So, next time you feel the warmth of the sun or the chill of a winter day, remember it's all about the kinetic energy of those tiny particles. Section 7. Melting point, from solid to liquid. Have you ever wondered how an ice cube turns into a puddle of water? It all comes down to something called the melting point. The melting point is the specific temperature at which a solid transforms into a liquid. For water, the melting point is 0 degrees Celsius or 32 degrees Fahrenheit. When you heat an ice cube, its molecules start to vibrate faster and faster as they gain kinetic energy. At the melting point, the vibrations become so strong that the molecules break free from their rigid structure and start to flow, turning the solid ice into liquid water. Different substances have different melting points. For example, iron has a much higher melting point than water, which is why it takes a blast furnace to melt iron but only a sunny day to melt an ice cube. The melting point is a crucial property that helps us understand how materials behave at different temperatures. Section 8. Density, how much matter packs together. Density is a fundamental concept in science that helps us understand the world around us. Have you ever picked up a rock and been surprised by how heavy it feels for its size? It's a common experience that highlights the concept of density. Or wondered why a balloon filled with helium floats while one filled with air doesn't? This difference is also due to density. The answer lies in a property called density. Density is a measure of how much matter is packed into a given space. Density tells us how much matter is packed into a given space. The more matter in a space, the denser the object. In other words, it's a measure of how tightly those tiny particles are squeezed together. The closer the particles, the higher the density. Imagine two boxes of the same size. They may look identical, but their contents can make a big difference. One is filled with feathers, and the other is filled with bricks. Which box is denser? The answer is quite intuitive. The box of bricks, of course. This is because bricks are much heavier and take up less space than the same number of feathers. That's because the bricks are much heavier and take up less space than the same number of feathers. This is a clear example of higher density. Density is calculated by dividing an object's mass, how much matter it contains, by its volume, how much space it takes up. This formula is crucial in many scientific calculations. So a denser object will have more mass packed into the same volume. This principle applies to everything from rocks to metals. Density is affected by temperature. As temperature changes, so does the density of the material. When you heat something up, its particles move faster and spread out, causing the object to expand slightly and become less dense. This is why materials can change density with temperature. That's why hot air balloons rise. The hot air inside is less dense than the cooler air outside. This fascinating phenomenon is a practical application of density in our everyday lives. Section 9. The world of particles and mixtures. We've talked a lot about particles and how they behave, but did you know that most of the matter we encounter in everyday life is actually a mixture of different substances? From the air we breathe to the food we eat, mixtures are all around us. A mixture is a combination of two or more substances that are physically blended together, but not chemically combined. This means that each substance in the mixture retains its own properties. Think about a bowl of trail mix. It might contain nuts, seeds, pretzels, and dried fruit. all mixed together. Each component can be seen and picked out individually. Mixtures can be homogeneous, meaning the components are evenly distributed throughout, like salt water or air. In a homogeneous mixture, you cannot distinguish the different substances with the naked eye, or they can be heterogeneous, meaning the components are not evenly distributed, like a salad or a chocolate chip cookie. In these mixtures, the different substances are easily identifiable. The key difference between mixtures and pure substances is that mixtures can be separated by physical means. This is because the substances in a mixture are not chemically bonded. For example, you can separate the components of trail mix by hand or use a magnet to separate iron filings from sand. These methods rely on the physical properties of the substances involved. Understanding mixtures is essential in many areas of our lives, from cooking and cleaning to medicine and manufacturing. Knowing how to separate and combine substances can be incredibly useful. So next time you encounter a mixture, take a moment to appreciate the fascinating world of particles and their interactions. Whether in a lab or in your kitchen, mixtures play a crucial role in our daily experiences.